Hi, in today's tutorial we will use the DeepLabV3 model in order to segment objects in an image. So let's run the demo first. So let's run a demo and explain what we are going to do here. First of all, this will be our test image. As you can see, this woman walking on the desert, and this will be our code. As always, it will be part of the video description. We will load the image using OpenCV, and then we will run an inference. The inference will be using image segmentation of the MediaPipe task, as you can see here, and we will need to initialize the image segmenter using our model here, and we will separate the background and the foreground of the image and apply separate colors, the gray and the white. The white would be for the mask, the woman in the image, and the gray will be all the rest. And this image segmentation will use a category mask, which applies a category to each found item based on the confidence. So this will be our first part, as you can see here, the segmentation with both colors. And after that, we will take the original image, use the segmented object, and extract it out of the original image and blur all the rest of the image. So let's run it and you will see the result. It will be more clear. Great. As you can see, first of all, this is the two colors as promised. The gray is the background. Basically, the white is the object and the gray is all the rest. And here you can see this is the original image and this is the segmented object with a blur background. So let's move to the coding, and we'll explain it step by step. Let's start with the installation. It will be a very easy process. We will start with creating a new Conda environment. It will be based on Python 3.11. As you can see, I chose a name remove.bg. Of course, you can choose your own custom name. After that, after the creation, we will activate this Conda environment. Conda activate, of course. Conda activate. Next, we have to install two packages. The first one will be OpenCV, and please choose this version so we will get the same result. And next, we install the MediaPipe framework. The MediaPipe is an open source framework developed by Google, and basically it has the ability to run manipulation over video, audio, and contains machine learning pipelines. It's especially popular for real-time computer vision tasks, and we will use it in order to do our segmentation process. Next, you have to download both models, the DeepLab version 3 and the Magic Touch model as well. The first one was developed by Google. The second one was developed by Alibaba, and we will use both models in our next tutorial. After downloading the models, put it on your local folder so it will be available for our coding. So after that, we are ready to continue with the coding part. Of course, this installation file and all the rest of the Python files will be as a link in the video description. After the installation, before starting the coding, don't forget to change your current working Conda environment. It should be by pressing Ctrl, Shift and P. Then you should select interpreter And these are all my Conda environment, and I will choose this one, remove BG. And now we are ready to start the code. Let's create our new Python file. Let's name it image segmentation, and using MediaPipe, and let's add also the DeepLabV3. Great. We import the OpenCV library. It will help us to read and display the image. We define the path for the image that we want to segment, this woman in the desert. And then we will use the OpenCV, the ImRead function, to load the image from the disk into our memory. Okay, now it's the ImRead, and then we will display the original image in a new window, and we will wait for a keystroke. Let's run it just to see that we are loading it correctly. Great, as you can see, here is the image. Now we will import the required libraries for image segmentation using MediaPipe. We will import MediaPipe as MP and NumPy as NP. Now we will import the vision module, which includes the image segmentation capabilities. And next we will set the background color for the segmentation results. It will be gray. Here is the one. And next we will set the foreground mask color, and this will be a white color. Great. Now we will initiate the MediaPipe model options, specifying the path for our TF-Lite model file that we downloaded already and put it on our local folder. So as you can see, now we are defining the arguments. Now let's look for our file. Here it is. I store it here, and let's also copy the full name, and let's put it together. So this is the path for our model. Next we will configure the segmentor with our model options and enable output of category mask. After that, we will create an instance of the image segmentor using the provided options. We are using the function named create from options and sending the previous value, the variable options, to this function. After that, we load the image using, please notice, the MediaPipe internal image representation. And then we perform segmentation on the input image and retrieve the result. Segmentor.segment, and we are sending the loaded image. Then we extract the category mask, which tell us which parts of the image are foreground. Then we will convert the image to a NumPy array to allow us to apply NumPy's operation. After that, we are creating a blank image, the same size as the input, filled with the foreground mask color. Then we create another blank image for the background, filled with the background color. Now we will create a Boolean mask based on the category mask, where values greater than 0.2 that are considered as foreground. This will be our condition. And next, we will use NumPy's where function to blend the foreground and the background images based on the mask. And this will be our output image. Now we just have to display the segmentation result in a new window. Let's copy the wait key, so now we can demonstrate two images together. So on the left side is the original image, and on the right side this is the segmented image. The object is white and all the rest is gray. Now let's move forward and segment the person with original image, but we will blur all the background. So let's start with convert the image to BGR color space to match OpenCV default for visualization. So we will use the CVT color function. After that, we apply a strong Gaussian blur to the entire image to create a blurred background effect. And after that, we will create a slightly relaxed foreground mask to define the area that will remain sharp. And then we blend the original image and the blurred version so that only the background will stay blurred, and we will display the result. So now, as you can see, on the right side is the blurred image with the sharpened segmented object. On the left side is the original image. The process runs very fast. Thank you very much. I hope you enjoyed this tutorial. Bye bye.